right, guys, this is my third go-ahead on this one. So if I make an oops, I am not going to correct myself. All right, I'm going to correct myself. I'm just not going to do another video. We are taking a look at dimensioning standards today. So dimensioning standards, there are a couple of organizations in the world that create engineering standards that companies follow. The one that you're going to see used most often in our class is the ANSI. That stands for the American National Standards Institute, and they create the engineering standards that are used by many companies in North America. In addition, you may run into the ISO, which is the International Organization for Standardization. They create engineering standards for about 100 different companies. The United States military actually has two different organizations that develop standards for their use. DoD, which is the Department of Defense, and then the MIL, which is the military standard. In addition, you'll find that Germany has their own, and that includes standards for film for cameras. JIS is the Japanese industrial standard, and it's created after World War II for Japanese standards. And then you have CEN, which is the European Standards Organization. When we talk about dimensions, there's a couple things that you need to be aware of. This right here, the 1 and the 0.50, is referred to as dimension text. The dimension line is this line right here, along with an arrowhead. And then, of course, we've got these extension lines that help guide you to where that dimension is coming from. So these extension lines, notice how they do not actually touch the object lines. There's a little bit of space in between, but your eyes can follow them to where it starts and where it might end. So overall, this is 1. We don't know if it's inches or centimeters. And then from here to here is 0.5. All right, so let's talk about the text. It's preferable for the text to fit in between the dimension line. But as you can see in this case right here, this is too big to actually fit here. And in that case, it is fine to have it placed on the outside. You've probably already seen this happening in Onshape for you. All right, dimension text guidelines include having it in the middle of the line, both horizontally as well as vertically. Dimensions are represented on a drawing using one of two systems, either unidirectional or aligned. You start with one and you stick with one. The unidirectional method looks like this. The dimensions are placed so that they can be read from the bottom of the drawing sheet. This method is common in mechanical drafting. And then there's the aligned method. Notice the difference up here compared to here. The dimensions are placed so that horizontal dimensions can be read from the bottom of the sheet, and vertical dimensions can be read from the right side of the sheet. This is very common in architectural and structural drafting. All right, there's two major types of dimensions, ones that tell you about the size and ones that tell you about the location of a feature. So the size dimension says from here to here, this is 1.83. From here to here, it's 0.52. But then you have dimensions that tell you about the locations of those features. We know that the center of this arc is going to be 0.71 inches from the side, and that the center of these from your top is 0.61 inches. Chain dimensioning is something that is quite common. You're going to see it's a common dimensioning technique. There are two types. This is method 1. Notice that the dimension is occurring from feature to feature across the entire part. So from here to here is 0.5, from here to here is 0.5, and from here to here is 0.5. Manufacturing inaccuracies can accumulate because of it. Let's say that this one is off by like 0.05, and this one's off by 0.02, and this one's off by 0.05. Now this entire overall dimension is off by 0.12. So that's something to take note of. Method 2 is the preferred one because it helps limit manufacturing inaccuracies. So while you know that this is 0.5 and this is 0.5, and you know that this might end up being 0.55 and this might end up being 0.52, by telling the manufacturer that the overall dimension needs to be 1.5, that's going to limit how long this actually ends up getting. And so it should still fit in the part with some inaccuracies going on right in here, which is going to be less of a problem. This is the preferred method where you take out one of these dimensions from the chain and give an overall dimension instead. It would be over dimensioning if you put that other chain of 0.5 in here. This is when Onshape starts to scream and turn red at you. And we don't do this definitely in the technical drawing that you create for it. You don't put the extra dimension in here. You guys have already experienced it where we can have the 3D CAD program on do the math for you. All right, the next one is datum dimensioning, and it's going to come from a single point of origin. It will reduce dimensional deviations in manufactured parts because each size or location dimensions is referenced to a single point. So they give you this example right here where single point referencing from one spot. So from here to here, from here to here, and from here to here. Notice the chain dimensioning happening here of method 1. Same thing here is that you have it all coming from one point. Here we have some dimensioning symbols that you guys are going to start getting more and more showing up in your items. Diameter symbol you should be familiar with, your radius symbol, counter bores and counter sinks that has to do with screws, and we'll start seeing that in the next semester, I believe. Depth of a hole, how many times this is going to happen. Plus or minus symbols, you'll see those quite often with tolerances. An arc symbol, a slope symbol right here. These other ones you may encounter, just not as much in this course. Moving on to dimensioning at an angle, there are 2 ways to do that. You can do an angled surface dimensioned using coordinate method that specifies 2 location distances of the angle. So this is an example of the coordinate method where you know from here to here is 1.75 and from here to here is 0.88. And then with this information, you're able to figure out where that angle is going to be. Another method that you guys have already encountered with the last activity is the angular method, where you click from here and you click here and the angle is going to be 30 degrees. And so you can type that in. Chamfers and dimensioning of chamfers. Chamfers are used on outside edges to avoid sharp corners for safety and handling. And a lot of times I'm going to tell you guys with your chamfers that you need to give me a soft edge for pulling off your creations from our 3D printer. So the bed gets really hot and it can be really hard, not hot, but when it cools, it can be really hard to pull off. And so if you have a chamfered edge or a rounded edge, it makes it easier to pull off. You have 2 options for 45-degree external chamfers. Notice how it's written as 45 degrees by a 0.125, or you can say 0.125 by 0.125. So that's giving you the information here. External chamfers other than 45 degrees would be done like this. And then internal chamfers going on the inside here, 60 degree, and now you know the length as well. Dimensioning of arcs and circles. They are dimensioned in views that show the arc or the circle. Arc should be dimensioned with a leader line to identify the radius, and sometimes the center mark is included. Circles should have 100% a center mark and are dimensioned with a leader line to identify that diameter. So here we have a radius of 0.125, a radius of 0.5. Notice it has the center mark on it. And you have the capital R for your radius. Moving on to Fillets and rounds. So these are rounded edges using a radius. These are fillets. Those are inside radius between two intersecting planes. Dimensioning of the circles. Full circles should be dimensioned using diameter. Notice the diameter symbol. Notice this tells you the depth of 1. So this is going to be a diameter of 0.5, and it goes down 1. We don't know if that's centimeters, millimeters, inches, or what. Dimensioning circles are going to have automatic cylinders, and they may be dimensioned in this manner like this. Okay, cylinder here, there's a cylinder here, and the cylinder here. Notice the right side view. Note that the diameter symbol is used so that the dimension is not assumed to be linear. Let's take a look. This is the windshield of the Automobilox vehicle. This is for splines. Points are placed along the contour of the splines and dimensioned from a datum. So this point is the datum, this bottom part. And that at this, about 8.5, let's say it's inches away, is going to have an approximate height of 1 inch. At about 7 inches from this spot, it's going to have 1.9 inch dimension, and so forth. All right, reference dimensions. An X indicates the number of places or occurrences. So the 2X right here indicates that there are 2 identical holes. Notice this hole has no information, but that information is actually going to be found here. 2 times identical. So it's going to have a diameter right here of 0.25. That hole goes all the way through. This is a counter bore symbol with a diameter of 0.38, and it's going to go to a depth of 0.25. All right, dimensioning of your radial patterns. Angles and radius values are used to locate the center of radial patterned features. So you have a circle here, and then right here on this circle, you're going to have more circles. So how do you figure out where they're supposed to be placed? Well, if you take a look, the center to the center here is 45 degrees. The center of this one to the horizontal center here is 45. And then this one has a different pattern. From this point, it's going to be 30 degrees. And then these 2 circles are 30 degrees from each other. And that is it for the dimensioning standards.